We are at the engineering design show. I am with Ian Wood, technical sales manager for Rochester Electronics. So for members of our audience that are unfamiliar with the Rochester brand, can you just give us a summary of what your organization does?
Okay. So Rochester Electronics is a distributor and manufacturer of semiconductor components, primarily in the end-of-life and legacy areas. We have a large stock holding, billions of parts in the US. We're a US brand out of Newburyport, Massachusetts. We're manufacturing devices now that went end of life 20, 30 years ago. So keeping some of the technologies that have died alive and supporting many different application areas.
Right. Just give me a bit more detail on that. So you're both like a distributor and a manufacturer.
Yeah.
So the business is kind of in two distinct parts.
So we started off back in the 80s working with manufacturers. So we're always working with an approved source, a manufacturer of semiconductor components. I believe one of the first was Motorola. So our founder, he was originally a Motorola employee. He went off and he could see that Motorola were essentially binning the components at end of life.
Wow.
And he decided that it was a great opportunity, and it was something that the industry needed. And that's why we come through to stocking end-of-life products. So we're talking with the manufacturers when the product goes end of life. After the last time buyers with our customers have gone past, and then we're securing stocks at that stage. And then I guess the next step of that is manufacturing and taking wafer and die to actually produce the parts.
Sure.
So sometimes it's easy to get the finished goods. Sometimes you get wafer and you can manufacture the devices.
And what you mentioned 20, 25 years there. What's the longest duration?
I think we're still stocking some devices from the 80s. So we still have things like 486s, 186, C186s, some old Intel processors. But yeah, as you can imagine, components that go around that as well. So interface, all sorts, memory.
You're here at the engineering design show today. Obviously, come to join us on our podcast here. What other things have you been up to at the show? What get out the show?
Just really walking the show. Obviously, getting to talking with contacts that I've made over my career. Seeing what the trends are. Seeing if there's anything new or exciting. Doing a bit of research. So a bit of all of that, really.
Cool. Your job title. Does that get you? I'm trying to envisage how Rochester engages with its customers. Are you boots on the ground? Or are you?
So my role is to support all of our customers across Europe. Right. I'm more of a technical resource for our sales team. So I sit in between the sales team and our manufacturing and our marketing teams that buy the components. So I'm a bit of a link between those two areas. Obviously, we've got the sales team across Europe. All in the different countries. I will visit customers. I'm out to Finland next week, visiting customers, and I do spend a lot of time with different customers, understanding their needs, what they have going on, and trying to answer all of the questions that they can't get answered.
Let's just expand on your role there, acting as technical liaison between the end facilities. Can you give me an example? It might be quite good fun just to have an example of the sort of questions you get hit with. What are the most common?
Anything. We get questioned whether the part is exactly as the original manufacturer, and then there's an explanation of who Rochester are, our relationships we have with our manufacturers. And the answer to that is that it's always the original manufacturer's device. It's the same part number, it's the same data sheet. Even if we're manufacturing it, we're manufacturing to the exact same standards. The test is exactly the same as well. Right. We wouldn't be able to mark it up with the same part number otherwise.
Yes. Okay.
But yeah, anything else in between, as you can imagine, it could be a question about Roche. It could be, it could be anything technical, cross-referencing. Sometimes we haven't got exactly what the customer requests.
Yeah.
We might have a different part number or several other part numbers that could be of use to them.
Could be used. Yeah, interesting. Yeah, so all the way through. Yes, I'm guessing, if you've got parts going back that many years into the past, then today's materials that you'll be working with, if you're repackaging them, they're going to potentially be different. So
we still sell non-Roche products into defense applications or applications that were way before that. So
yeah, interesting. I can imagine every day is a learning day.
Yeah. And there's always unexpected questions. That's what keeps it fun. That's why I do it. It's the interesting side of the business is you never know what's going to come up in your day.
Yes.
One day I might be at a trade show. The next day I might be looking at a spreadsheet of 180 different parts, evaluating that, looking at their lifetime, and giving feedback to customers and things like that.
Yeah, brilliant. So give me an indication as to the market breadth that you guys deal with. I'm interested to know sort of where you fit in there, and which industries you think are going to be showing the growth over the next, say, maybe 2 years.
Okay, so any industry really, they're all affected by end of life and lifetime of the life cycle of a semiconductor. But primarily we do a lot of business with aerospace and defense. We do a lot of we're working a lot in long lifetime applications in the industrial market, the rail market, things like that. Definitely areas where they have certifications. The cost to redesign is huge. And obsolescence is a big issue for them. But even some of your day-to-day applications, one part goes obsolete on a board. Do they redesign the whole board as a result of that one part going obsolete, or do they wait for 5 parts on that board to go obsolete or end of life?
So it's going to be, I guess, the expected longevity of that product, the value of the board, the industry sector in terms of certification and regulation. You're going to have a kind of matrix of that to determine where you guys fit. Are you seeing any industries at the moment? Obviously, now the dominant industry at the moment seems to be the AI sector in terms of its sort of sucking capacity out of traditional chip production. I think
that affects a lot more of the wider market than it does itself, because they're always on the leading edge of technology. Whereas we're often looking at the trailing edge, which is being affected by AI. For instance, the memory market, you're looking at memory, and the main memory manufacturers want to produce DDR5 and high bandwidth HBM. They don't want to deal with the lower technologies, which is what most of them, the industrial market, the medical market, aerospace market, all of those other industries, they use those lower technologies, those non-leading edge technologies.
It's interesting on that subject. Everybody's talking about the GPU stuff, the exciting there. But the undercurrent of that, as you just mentioned, is memory. So can we expect there to be down the stream obsolescence issues coming through in the memory sector?
I'd expect it.
AI switch.
I mean, we've seen some of it over the recent years. And I've been working in memory for a bit, so I kind of understand it as well. But things like DDR3 and below could be problematic. I think DDR4 is a challenging area at this moment in time. There's a restriction on production, and lead times will go out, and the market will have to adapt. And obsolescence is one of the ways that the manufacturers deal with the inability to be able to produce something.
So you're in a good position in terms of being able to stock hold, and can you remanufacture as well? Memory?
Some memory, some of the older technologies. So we still make things like EEPROMs. We've got some parallel flashes as well that we're now producing. So Some of the older technologies, certainly.
Yeah.
The newer technologies, not so much yet, but who knows what can happen in the future.
It's interesting because I remember back in the day when it was the mobile phone industry that was triggering a lot of obsolescence. It was often things like capacitors that caught everyone by surprise when everyone was assuming it was going to be comms chips and things. So yeah, it's interesting. You know, from your customer's perspective, I imagine, you know, concentrating everything around the CPU, etc., but not forgetting.
Yeah, I mean, the way I like to look at it on a board is think about what your parts are that are critical to your design. What would require a significant amount of redesign? What's central and important? So when we talk to customers, CPU is important. But if you've got an FPGA on the board, if you've got memory on the board, any specific analog parts that you might have on the boards which are sole source to a certain supplier. Think of them as critical, and that's the sort of information that you need to be sharing with Rochester so that we can, if we see end of life, we can then react. So a lot of the time the customers are sharing that information with us before anything's gone end of life. And then we can come back to them when that happens, when we're aware of it, and say, hey, what are you doing about this end of life? Have you seen it? Are you aware of it? What are you doing? How many pieces are you buying into the future? Do you have a longer requirement for parts? Do you have a 10, 15, 20-year requirement for parts? Because a last time buy can't support you for that sort of time. It would be a massive investment for any company.
Just talking about memory a little bit further, I'm going into a bit of technical detail and we're going beyond the fireside chat because questions keep arising.
That's okay.
With memory, you know, what do I think about? I think about capacity. I think about package and footprint, that sort of thing. Give me a clue as to some of the other variables. There's power, an issue with memory or different.
You've obviously got different technologies, so you can't go from DDR1 to DDR3 that easily. So you'll be kind of limited in that. You've got the different widths, so you might have a 16-bit wide part, 32-bit wide part,
right,
or even an 8-bit wide part. So that's all different. Obviously on capacities, as parts get older, the capacities grow. That can be kind of managed. But if you put a smaller part in a design and now it's on a bigger part, is that able to be qualified in the design? So there's many different variables. Just look at any part number, how it's built up, speed grades, temperature grades, special package options, environmental, dual die, single die, all sorts of things like that. You can kind of
so a big matrix.
It's a massive, and as the technologies get more and more complex, our job gets more and more challenging in some respects. The older technologies are a little bit more straightforward, but the newer.
Just to throw a real curveball in about things like sort of radiation hardened products and that sort of thing for the space industry.
Sometimes we're getting involved in that. Obviously, we're an American-based company. There's a lot of military-grade parts which are radiation hardened, standard. So sometimes we are getting involved in that sort of product team.
But in terms of sort of industry growth, where do you think growth might come from over coming years?
I still think we're gonna have a very strong focus on aerospace and defense. We work very heavily in that area. I think we'll start to see more in automotive. Maybe. So we don't have as much. We don't have the big share that some of the others have. And I think that they're going to see more and more. I think industrial will be a big market for us, and medical as well. All of it.
Everything's going to grow.
It's all going to grow.
I'm thinking about automotive. It's an interesting one because the more I look at the networks in modern vehicles, you're looking at battery management, highly regulated and critical, driver assistance, all that sort of thing. So you're into printed circuit board assemblies there that are going to require very high levels of compliance and that sort of thing. I don't know what the planned longevity of the EV is these days. It's got to be a decade or longer, I guess. Do you think those types of more advanced devices you'll be supporting those.
I think so.
And
I think we're certainly working with a lot of manufacturers that are supporting the automotive market.
Yeah.
And I can see as their business kind of moves on to newer technologies, they'll want a way to support the older technologies.
Yeah.
In the automotive market. It's an interesting market for us.
See how it pans out. Yeah, it's cool. Right, we'll start to draw the interview to a close. So how do people get in touch with you guys? What's
all of the usual social medias, we're very present on LinkedIn. But look to our website, rochester.com, which is continually being updated, and it's got a lot of information on there. Obviously, connect with the direct people. We've got a large team in Europe. There's probably somebody quite close, locally situated to you,
right?
That can talk in your own language. But there's people like me there in the background, able to support you with any technical questions you might have.
So they can contact you digitally. They can give you a call.
Yes.
If it calls for it, can they come and see you, or can you go and see them?
Yeah. So we're continually visiting customers. We're still out there face to face with companies, meeting them and discussing their requirements. So happy to do face to face meetings. Or Teams if that's required as well. So we're fully available for.
Yeah, brilliant. Right, now I'm going to throw in two curveball questions. Who in history would you imagine is your engineering hero, and why?
Well, I'm thinking back to kind of Victorian times, like Brunel or somebody like that. There's so many things of his that are still present in our day. You've got to think of him as somebody that's engineered something pretty strong and reliable, and it's from that perspective. A
genius.
A
genius.
And different areas as well, different technologies and things like that. So he's a true engineer. He's not just one trick pony.
Yes, brilliant. And my final question: if there was one innovation that you wish you'd invented, what would that be?
I'm not sure. Maybe something like the laptop. I think it's something that we all look at, and maybe it could have been something different if it was originally thought about differently. I don't know. That's something that's ever present in our lives.
It's fascinating. I remember back. I'm old enough to remember a world before computers. And I remember Tomorrow's World and all those programs suggesting that one day you would have a computer in your lap. At a point in time where a computer filled an entire room. And so, back in those days, it was an impossible dream. And now we've got more computing power than you could ever need.
It's crazy that this watch is more powerful than the computers we had originally.
Brilliant. Well, thank you very much.
Thank you.
It's been a pleasure speaking to you. Now have a great show.
Thank you very much.